Okay, accordingly that we have got the net output voltage. So by moving the plates, removing the plates. Okay, so we have calculated the change in capacitance that I have shown the calculation part, and already that shared the materials also for your reference in Google Classroom. I hope that you have already got it. So that is the problem. Read the problem very carefully. That is a capacitive transducers that is consist of two triangular plates. Okay, two triangular plates. These two plates are triangular. Okay, triangular plates. That's placed side by side. Okay, that's placed side by side with a negligible gap between them. Negligible gap means this gap. Okay, you can see this gap is very negligible, or you can consider it as zero. Okay, very negligible, this gap. Okay, and a rectangular plate. That rectangular plate means this is a rectangular plate. Okay, so that is moving laterally. That is moving laterally in this way. Okay, so that is moving laterally. So that means what? A moving plate is there, and the back side of the moving plate there are two fixed triangular plates are there. Okay, so that this moving plate is this rectangular plate is moving laterally. Okay, so this is the fixed plate and this is the moving plate with a uniform gap of 1 millimeter between the plates. Okay, that means the air gap 1 millimeter between this moving plate and the fixed plate. So air gap is a 1 millimeter. Okay, so this is a diagram actually. Okay, so this diagram is given to you. Okay, so this diagram is given to you. So if this type of diagram is given to you and the problem statement is there, so with the position of this moving plate, position is there, moving plate position, this is the moving plate position. Okay, it is placed in this side. Okay, so moving plate position, you have to find out the capacitance C1 and the C2. Okay, so capacitance C1 means capacitance between this first triangular plate and this moving plate, and capacitance C2 means the capacitance between the moving plate and the second triangular plate. So there's C1, C2 that you need to find out this capacitance value. Okay, so this is given 10 centimeter. Okay, triangular plate. This is given 10 centimeters. Okay, this is 10 centimeters, and this is the total distance. That is given. Their length is given 20 centimeter. So 20 centimeter means so it is divided in this way. So as the moving plate placed, it's moved in the right hand side and it is placed in this position. So this is the 10 centimeter. This is the 4 centimeter, and this is the 6 centimeters. Okay, so that's why it is divided. So total is the 20 centimeters. Okay. So now you have to calculate C1, C2. How to approach this problem? Sorry, okay. How to approach if this is given to you in exam, this type of numerical. So first thing is that see. So we know that the formula of the capacitance is what? What is the formula of the capacitance? Formula of the capacitance is, that means C equals to
epsilon A by D.
Epsilon A by D. C equals to epsilon A by D. Okay. So now what we'll do, suppose your C, this is the capacitance C, that is equals to epsilon A by D. Okay, that is a C. Okay. C equals to epsilon A by D. Okay. So now, what is the epsilon actually? Epsilon actually, that is a absolute permittivity. Is a product of absolute permittivity. We can write the relative permittivity into area into this distance. Okay, that is a D. So as this is the air, there is a air gap. So that means it is a free air. So that is the relative permittivity we can consider, that is a 1. Okay, and that the value of the absolute permittivity, so that is a standard value. So that is 8.85. That is the value 8.85 into 10 to the power minus 12. Okay, 8.85 into 10 to the power minus 12. So that is absolute permittivity value. So the distance, so that distance is given, that distance is given what? The distance is given, that is 1 millimeter. 1 millimeter. Okay, 1 millimeter means the gap between the moving plate and the fixed plate. Okay, moving plate and one fixed plate. So that is a 1 millimeter. So D is given 1 millimeter. Okay, so you have to solve with respect to this diagram. Okay, this diagram. So now the
here we have capacitors, right?
Yes.
So like two will be between two triangle, one will be between the rectangle and one triangle, and the third will be between the second triangle and the rectangle.
Secondary rectangle, because first capacitance, this is capacitance across this moving plate, this one, and this fixed plate one. Okay, and the capacitance 2, that is this moving plate one and this fixed plate one, C1 and C2, C1 and C2, two capacitors.
There should be C3 also, right? Between the triangle also.
Between the triangle C3 also there, maybe there, but it is not shown here. It's not shown here. Okay, so you have to calculate only C1 and C2. You have to calculate only C1 and C2. Okay, because when the moving plate changes in this position or in this position, in this way, in this side or in this side, so then the capacitance automatically changes. Okay, so that thing you have already studied in the differential arrangement. So capacitance, virtually we are measuring the capacitance between the plates. Plates means one is the moving plate, another is the fixed plate. Okay, one is the moving plate, another is, so that is why it is C1 and C2. That's why you are considering C1 and C2. Understood? The two capacitors, C1 and C2. Got it? So now look the diagram. In this diagram, so what is the formula that we have already written? That is C equals to epsilon A by D. C equals to epsilon A by D. So now D is a 1 millimeter. That is distance, uniform air gap. The distance that is given, between the the moving plate and the fixed plate is given. That is a 1 millimeter, right? So now what you have to do? What you have to do now? You have to find out. You have to find out the area. Okay, you have to find out the area. Area means the overlapping area. Okay, so overlapping area means this is the overlapping area once. This is the overlapping area. This is a one overlapping area. This portion. Okay, this portion is a one overlapping area. Okay, between the movable plate and the triangular plate one, and another overlapping area. This is the another overlapping area. Okay, between the movable plate and triangular plate 2. Okay, so this is your overlapping area 1, and this is your overlapping area, so that is your 2. So there are two overlapping areas. Okay, so you have to calculate first, that is a 2 overlapping area, because we know the value of epsilon, we know the value of D. You need to find out capacitor. So before obtaining the capacitor's value, so first you need to find out the value of area. Find out the value of area. So we will find out one by one. First we calculate C2, then we calculate C1. Okay, for the C2, when we are going to calculate the C2, so we need to calculate this overlapping area, because C2, the capacitance between this moving plate and the triangular plate 2. And when you are going to find out the C1, then you have to calculate this overlapping area 1, because C1 is the capacitance between this moving plate and this fixed plate, triangular plate 1. Okay, so first we will focus on C2. Okay, first we will focus on C2. So C2 equals to, we know that what? C2 equals to epsilon A by D. C2 equals to what? C2 equals to, we know that epsilon A by D. Okay, so now epsilon we know the value, D we know the value. Okay, this is known to you. You need to find out the value of area. So that is a A2. Okay, A2 you have to find out. This overlapping area you have to find out. Okay, so you know that if we see, so this is the trapezoidal. This is a trapezoidal shape. Okay, so this is the trapezoidal shape. Okay, so what we know actually in the trapezoidal shape, we know that how to find out the area. So this is your all is mathematical. So this is the trapezoidal. Yes, half into A plus B. Yes, half into A plus B, right? So that
Correct.
means, you know, yes, yes. So that means this is the two parallel plates. This is the two plates. Suppose we have given, let's say, A and B parallel plates, and you know this is the, suppose this is the height. So this is the h. So now what we can write here? So that is equals to h by 2 into h by 2, that is into a plus b. Okay, so that means half into a plus b. So h by 2 into a plus b. So that is, you know, the area of, you know, the trapezoidal. Okay. So now go back to the diagram. So in this diagram, see in this diagram, this is the overlapping area. So this is the overlapping. This is the overlapping area. We need to find out this one. We need to find out this one. Okay. So this is the A2. This is the A2. So first now, how to calculate? How to calculate it? See. This is the triangle. Okay. First triangle. This is second triangle plate. Okay? Second triangle plate. So this is the angle. You know, this is the angle. Okay. So this is the angle, right? So this is the angle, is the theta. This angle is the, you know, theta. Okay. So this is the theta. So what we can write here? Tan theta. Tan theta, what we can write? Because this is the 10 centimeter. So 10 centimeter means, you know, suppose this is the 10 centimeter. Similarly, so this is the 10 centimeter. Okay. And total it is given, you know, that is a 20. Okay. Total it is given. So that is a 20. So tan theta equal to what? That is 10 by 20. So tan theta, that is equals to what we can write? Tan theta equals to, we can write here, tan theta equals to, we can write here 10 by 20. Okay. So tan theta, that is equals to, we can write tan theta, that is equals to, we can write 10 by 20. So that means equals to half. Okay. Tan theta equals to 10 by 20. So that means equals to half. Okay. So that is equals to tan theta. Tan theta, clear? So now here tan theta you have to find out 10 by 2. Okay. So now what you have to do? What do you have to do? See it. You have this is the area. Okay. So you have to calculate you know, this one. Okay. And you have to calculate this one, because this is the overlapping area. Okay. So first, this is the two parallel plates. This is the two parallel. This is the two parallel. So you need to calculate this A value and you need to calculate this V value. Okay. You need to calculate. Okay. So first thing, when we will calculate, suppose when we will calculate you know, this one. Okay. Suppose we consider this triangle. This is the triangle. Okay. This is the triangle, right? So this is the triangle, small triangle, this triangle. Okay, this triangle. So this triangle, what we can write? Tan theta equals to this A by 10. Okay, tan theta equals to what we can write? Tan theta equals to A by 10. Okay, tan theta equals to what we can write? Tan theta equals to what we can write? Tan theta equals to, we can write here A by 10. Okay, tan theta equals to what? That is a A by 10 from this figure. Okay, that is a A by 10. Okay, A by 10, right? Tan theta equals to A by 10. Okay, so what is the value of, you know, tan theta? Tan theta already we know the value. Tan theta, what is the value of tan theta? That is equals to, we have got half. So A equals to what? A equals to 5. Okay, so we have got the value of A. So that is equals to what? We have got the value of A. So that is equals to 5. So this value we have already calculated. That is a 5. Now take this triangle. So this triangle means what? This triangle will be tan theta equals to B by 14. 10 plus 4. 10 plus 4. So tan theta equals to what? Tan theta equals to what we can write? That is a B by 14. That is 10 plus 4. Okay. So now what will be the value of B? What will be the value of V? B will become the value of B 7. Okay. B will 7. Right. So now the total value in our total value. So total value, it is coming in a 5 plus 7. You know, that is a 12. Okay, so that is a 5 plus 7, you know, that is a 12. That is a total value. 5 plus 7, that is a 12. Okay, and this is the height, you know, that is a 4 centimeter. This is your height, 4 centimeter. Okay, so this is actually, you know, that is a 4 centimeter. Okay, so this is the 4 centimeter. Okay, so now what we can write? So now what we can write in the, if we go back to the equation, so now go back to the equation, then what we can write? Yes. So now what we can write here? So A2 A2 that is equals to, A2, that is equals to, what is the formula? H by 2 into A plus B. So H by 2 means, that is 4 by 2. That is a 4 is given. Height is given 4. So 4 by 2 into 7 plus 5. 4 by 2 into 7 plus 5. So your A2 value has come. You have got the value of A2. Okay. You have got the value of A2. So this is your A2. So this is your A2. This is the C2. So C2 equals to epsilon into A2 by D. Okay. So you know the value of epsilon. We know the value of D, and we have obtained the value of area. So that is A2. Okay. So that is the value of A2. So if we put the value of A2 in this equation, then you can easily find out the value of C2. Then you can easily find out the value of C2. Okay. The method is clear. Let's see how you have calculated the value of capacitance across the moving plate and the triangular plate, fixed plate 2. Is it clear? Clear?
So could you explain how to find A1?
A1. Okay. So now how do you find out the A1? Okay. Same procedures. How to find out the A1? This is the of A2. So now how do you find out the A1? So in the case of A1, so this angle is the theta. Okay. So if you can consider this angle is the theta. Okay. So this is your theta. Okay. So now calculate, suppose tan theta. Okay. So tan theta value already we know. Tan theta equal to we already know. So that is equals to half. Okay. Tan theta already we know the value is equal to half. Okay. Now you have to calculate, this overlapping area. This overlapping area you have to calculate, right? So these are two parallel plates in this case. These are two the parallel plates. So suppose consider, this is the A and consider this is the B. Consider this is the A and this is the B. Okay. So suppose consider this is small triangle, this triangle. Okay. Consider this triangle, this one. Okay. Consider this triangle. So this triangle, tan theta equals to what you can write? Tan theta equals to A by, tan theta equals to what? A by 6. Tan theta equals to what?
Yes,
A by
sir.
6, because this is a 6. Yes or no? 6. Tan theta equals to
Yes,
A by 6. So A equals to what is the value of A? So A we are getting 3. A we are getting 3. Okay.
Yes, sir.
A we are getting 3. Similarly, tan theta equals to B by 10. Tan theta equals to B by 10. 4 plus 6, that is a 10. Okay. So this one. So now tan theta equals to half. So B equals to what? B equals to 5. B equals to what? B equals to 5.
Yes, sir.
Okay. So now the total value is coming like the overlapping area 1. So overlapping area 2. So overlapping area total value, this value is coming 8. Okay. This value is coming 8. Okay. 5 plus 3, that is equal to 8. So now same thing that you have to, that is the H by 2. A1 equals to, H by 2 into A plus B. So A plus B means 8 and H equals to 4. Okay. So 4 by 2 into A plus B. Okay. 4 by 2 into A plus B. Understood? So that is your overlapping area A1 and this is your overlapping area A2. Now is it clear to you? Is it clear to you? Okay. So this is thus you can calculate the value of also C1. Thus you can calculate the value of C1. So this is the very important problem. This is the radical problem. Thus you can calculate maybe triangular plate, maybe any plate. Okay, there's two parallel plates, triangular, maybe rectangular, whatever. Okay. So thus this method, this idea you have to apply in this way. Okay. So you have to calculate in this way. This is the radical problem. This is a very important problem. This type of problems you will face in examination. That's why I have chosen this one. Okay. So this is very important problem. Very important problem. So how to find out, because you have to hear the trapezoidal shape that you have to consider here. Okay. Then a combination, combination methods. All the methods are all combined here. Okay. So I hope that all of you have understood this problem. If you have understood this problem, then you will be able to solve any type of problems. No issue. Okay, they will not face any problem in examinations. Okay, any problems you can solve. If you have understood this one, then you will be able to solve any problem from capacitive transducers easily. Okay, easily you can handle it. Okay, so this is very important. That's why this is a problem one, only one problem that I have discussed today. Okay, this is an analytical problem. So I will share with you 2-3 problems, 2-mark question based problem, capacitive transducer in Google Classroom. You can practice for that. Okay, in your home you can practice for that. Okay, so this problem, is it clear to you all? This problem, all of you have understood?